the example problem. Alright, so let's do an example problem. I'm going to erase this. Okay, so let's say we believe that 15% of the population is left-handed.
This is an example?
Yeah, this is an example problem. Okay. So to test this idea, we take a random sample of, let's say, 300 people. And in our random sample, $51 people are left-handed. Okay. Does this provide evidence that the proportion of left-handed people is not equal to 0.15? Yes.
Is there like an actual formula to this?
I just described the process
Okay.
for this. Okay, there's not a formula that you just plug in numbers to and get an answer. It's a process. All right. So we believe that 15% of the population is left-handed. We want to test this, so we take a random sample of 300 people, and in our random sample we find that 51 people are left-handed. So, does our random sample provide evidence that the proportion of left-handed people is not equal to 15%? Okay, so we're doing a hypothesis test. We got one sample, one categorical variable. What is the first thing that we have to do?
PM.
Just wrote down the process for you guys. What's the first thing that we do? Yeah, we find our hypotheses. Okay, read the problem and determine the hypotheses. Is that okay? So, what is our null hypothesis? The null hypothesis for these problems are always in the form of what? Alright, H0 is that P is equal to something, right? So what do I write in my something here? P is equal to 0.15. That's my initial belief. I believe that the population is 15% left-handed. Now, it's not always going to be written in this clear cut, I believe that the population is 15% left-handed. Right? Say something like, researchers want to know if 15% of the population is left-handed, or, it might be phrased a little bit differently, but just to get us started, I'm keeping it simple here. So I write my null hypothesis is that P is equal to 0.15. And when we read the problem, it says, does this provide evidence that the proportion of left-handed people is not equal to 0.15. So my alternative hypothesis is going to be what? P is not equal to 0.15. So these are my hypotheses. P being the proportion of people who are left-handed. Yes?
Will it ever say like the proportion of left-handed people is greater than 0.15?
Yes, we might have to, the question could be written that way, and we would have a different alternative hypothesis. But with the way the question is written here, our alternative hypothesis is that P is not equal to 0.15. Okay, what does our data show? So we look at our data now, and from our data, what do we find? How large is our sample?
300.
N is equal to 300. And what is my P hat? P hat is not 51.
15.
P hat is 51 divided by 300. 17%, 0.17. Okay. So do not write P hat is equal to 51. P hat is always a proportion. So your proportion always has to be between 0 and 1. So if you're putting in a number larger than 1, you've done something wrong for your sample proportion. And now we want to find our P value. What is the P value again? The P value is a probability. It's the probability of what?
Observing your data.
Yeah, observing our data if the null hypothesis were true. So we're saying if the population is only 15% left-handed, what's the probability that I take 300 people and I end up getting a sample that's 17% left-handed? Is that likely to happen or unlikely to happen? Okay, you guys are saying likely, but let's do the math and figure out the answer here. Okay, so we want to know, we want to find the p-value. Okay, so is it likely or unlikely? That's essentially what we're asking. Is it likely or unlikely for a random sample to have 17% left-handed if the population is 15% left-handed? That's what we want to know. Okay, so how do we do that? We get a z-score, right? So z is going to be equal to what? What did I observe? I observed 17%, and I'm expecting 15%, right? If the null hypothesis were true, I'm expecting 15%, and I divide that by my standard error. So what is my standard error? Okay, so my standard error is going to be, use what? 0.15 or 0.17 here? 0.15 times what? 1 minus 0.15 divided by 300. Good. So my standard error would do this calculation. I get a standard error of 0.0206. Sound okay? So what is my z-score?
9708.
0.17 minus 0.15 divided by 0.0206. Again, my z is equal to 0.97. what do I do?
Look at the
Look
table.
it
I look it up in the table. Okay? Now, I drew out 3 scenarios. I said if the alternative hypothesis has a greater than, less than, or if the alternative has not equal. In this case, we have alternative as a not equal sign, so what does my shading look like? I'm looking at both sides. So I'm going to look up 0.97, and I'm going to find the area to the right, in the right tail. And then what do?
Multiply by 2.
I multiply it by 2, okay? Because I'm going to go to both sides here. So how much is in the tail here?
Times 2.
Yeah, well, so tell me how much is in the tail, and then we're going to multiply that by 2.
0.834.
So the tail does not have 0.834, the tail has
Oh,
1 minus that, right?
So you gotta look at yourself. You gotta look at
Okay, so
0.8340.
when you look up 0.97, you get 8340, right?
And 1 minus
0.332.
But 0.8340 is the area to the left of 0.97. And we want the amount over here. So I do 1 minus 0.8340, and I get 0.1660, and I multiply that by 2 because I'm also going to have 0.1660 over here. So my 0.1660 times 2, 0.3320. 0.3320. I want to make sure everybody's okay with this. So I'll give you guys a moment. Make sure you can figure out getting 0.1660 and 0.3320 on your own. And if not, raise your hand.
Wouldn't it be the other way around?
Dan?
So first do 1 minus 0.8340, and then after that we apply that answer.
Yes. So in this case, I want to know how much is in this piece of the picture over here. So when I look at 0.97 and I look it up, I get 0.8340. But that is the area to the left. I don't want that. I want over here. So how do I do that? 1 minus that. I get 0.1660.
Now we multiply that by
But I have this one over here, and I also want to get this one over here, which is exactly the same size as this. So I multiply it by 2. And I get 0.3320.
For that side.
For both sides combined, I have 0.1660 on this side, and I also have 0.1660 on this side.
And you add them, you get.
And I add those two together, I multiply by 2, and I get 0.3320. Yes.
Because normally you would be using the whole left side, whereas this time you're only using partial of it. Why are you doing the 0.1660? Like normally, if you're doing these for 0.97, you get
So when I look at 0.97, I get 0.8340.
right, and that's.
But I don't want the area to the left. I want the area to the right multiplied by 2. So to get the area to the right, I do 1 minus that. And I get this part is 0.1660.
And it's equal to the other.
And then that's equal to the other part, and I multiply by 2. So my p-value is 0.3320. So that is the probability of observing our data if the null hypothesis are true. So if the population is exactly 15% left-handed, how likely am I to get a sample of 300 people where 17% are left-handed? It happens about 33% of the time. Okay, so it happens quite often. So does this sample give me reason to reject my initial belief?
No.
It does not. Does it prove my initial belief? No, it doesn't prove that this is true, but it doesn't give me any reason to doubt this.
said how low is the percentage have to be for you to reject your initial hypothesis?
We said a good rule of thumb is 5%.
5%.
So here I'm getting 33%. Okay? So I'm going to say, let me erase this over here. So we get our p-value is equal to 0.3320. So about 33%. So that means if the population,
I have a question. If it's not rejecting it, it's not accepting it, what would be the answer?
it's not rejecting the null hypothesis.
It's not rejecting it? So then it's accepting it.
It's not accepting it. We're not rejecting the null hypothesis.
Neither or.
The answer is we're not rejecting the null hypothesis. That's all we can say. Not rejecting the null hypothesis. That's the conclusion. Let me write this, okay? So if the population is 15% left-handed, then the probability of taking a random sample and getting 17% left-handed is not unusual. It happens about 33% of the time. 33.2% of the time. Okay, so our conclusion, so we have no reason to reject the null hypothesis. Okay, so we do not reject the null. We do not reject the idea that the population is 15%.
It'll be clear, like percentage-wise, that it would be either rejected or not. You won't give us like a 7, 6%, something like that. Would it be like
Well, if I did, I would give you an alpha to make that decision. I would say use alpha for significance level equal to 5%. And that would be your deciding factor. Okay? So if you get 5.3%, it's bigger than alpha, don't reject it. If you get 4.7%, it's less than alpha, you would reject. Okay. Was this problem okay? You guys want to try one on your own?
Yeah.
Yes? No?
Yeah.
Yes. Okay. So I will put one up on the board for you guys to try on your own. Okay. So just remember the process. Determine your hypotheses. See what the data says. Then find the p-value and the probability. So I'll leave this up here as kind of an example. But of course your problem will be different. Don't erase this yet? Okay, I'll give you another few seconds before I erase it.
say that was like 6%, right? Can you show me, like, can you show us how, what would you do in alpha? Like,
You would just compare the alpha.
like if it's greater than alpha or less than alpha?
Yeah. Because I think somewhere I told you, if p-value is less than alpha, you reject the null. If the p-value is greater than alpha, do not reject the null.
And you said the p-value, we take it as 0.05.
Yes. I'll tell you what alpha to use. Okay.
Okay.
If alpha isn't given, we already
I'm sorry.
If alpha isn't given, we should already assume that.
That's correct. If alpha is not provided in the problem, assume that you're using alpha is 5%. Okay, so I'm going to erase this and put a problem up for you guys to try out. Okay, so a certain company claims that 4 out of 5 dentists would recommend their gum. Or let's say 80% recommend their gum. Okay? A consumer group surveys, let's say 400 dentists, and finds that only 296 of the dentists recommend the gum. Does this provide evidence that the proportion who recommend the gum is actually less than 80%? Okay, let's try that out.
What does PH stand for? What does PH stand for? I mean, HA.
How are you guys doing? You guys need another minute?
Yes.
Okay.
Can I ask you?
Yeah, you can ask me a question.
So, this is all the but then I'm wondering. I was looking at this.
You want to use 0.8 as a but other than that, it looks okay.
I used the 0.8 there.
This is true.
So you want to do 1 minus that.
Oh, for what? Because it said.
But not one, so you looked at the cost of these sorts negative.
Right after I got it. The way you don't reject it is because you get negative. The way you know it is because this is negative 3. We look at your Z table, and it's 0.001. Putting that into a percentage, the percent is 0.13. So 0.13 is very unlikely. If it's 0.13% of the time this is true, that means it's very unlikely. That only 0.13% of the time, this is true. This happens. Forget that. So look, at the end, your final answer is 0.003, right? So you grab 0.003, it changes the decimal. So you keep the decimal to the right. 0.13%. Right. So 0.13, so if you get that in a sentence, it goes 0.13% of the time, this example that he gave us is true. So 0.13% of the time, that rum is actually less than 8%. So only 0.13% of the time that problem is true.
Alltså om det står någonting
Yeah.
equal och du säger det är
You don't kind of like, the only time you gotta do one is that
bara lika med P eller Okej, alltså det är här texten.
Some question was asked.
Eller om du säger equal.
So like for example,
Men jag tror att det är det för att förra frågan var antingen ska det vara equal eller ska
Okay, looks like a lot of you guys have gotten pretty far or figured out the answer or something. All right, so let's talk about our hypotheses and then we'll look at our data and we'll go through the problem.
Ja.
We won't go home because we've got another entire test to learn.
Wait, what? Oh,
Yeah. I know. Happy Thanksgiving. Alright, so determine the hypotheses. P is equal to 0.8, right? This is the claim that we are testing, or the belief that we're going in with. And the alternative says, does this provide evidence that the proportion who recommend the gum is actually less than 80%? So our alternative is going to be P is less than 0.8. That's what we want to test. Okay, is that okay? Just want to make sure that we're good with the less than here. So the data is we have surveyed 400 dentists, and we found that 296 out of 400, or 74%, recommend the gum. And we want to know what's the probability of us getting 74% if truly 80% recommend the gum. That's what we want to know. So we're going to do our z-score. So our z-score in this case is 0.74 minus 0.80 divided by our standard error. And this is a common mistake that students make. But in your standard error, the number that you want to use is not 0.74, but the number that appears in your null hypothesis. Okay? So it's going to be 0.8 times 1 minus 0.8 divided by 400. And when we do this, we should get 0.02 exactly. Yes?
For your alternative hypothesis, why the last one it was P does not equal to 0.8, so this one 0.8 is greater than P?
I'm sorry, can you repeat your question?
On the alternative hypothesis, why is it P not equal to 0.8?
Or you mean less than?
Yeah, there. Why is it not equal?
Yeah, so
The
here
last
it-
one was.
Yeah, because the question is written in such a way that it says, does this provide evidence that the proportion who recommend the gum is actually less than 80%? Okay? If I had written the question as, does this provide evidence that the proportion who recommend the gum is different from 80%, then I would say not equal. I could also ask, does this provide evidence that the proportion who recommend the gum is greater than 80%? Then I would say greater than 20.
The last one you said not equal to 0.50. That's why you put it.
That's what. So you got to read the question carefully when we do this. Okay, what if I've written, does this provide evidence that the claim of 80% is too high? So we're asking if the claim 80% itself is too high. So in that case, it would be P is less than 80%. Okay.
80% is too high from the
Versus what our data reveals. Okay. So there's some careful reading that you have to do to determine your alternative hypothesis. Okay, so anyway, going back to this, our z-score is 0.74 minus 0.8 divided by the standard error. 0.74 minus 0.8 divided by the standard error, which we determined was 0.02, and we get a z-score of what? -3. Z-score is equal to -3. I go to the z-table, I look up -3.00, and what do I get? 0.0013. That's the area to the left, and that's what I'm going for because my alternative hypothesis has a less than sign. I'm not going to multiply it by 2, I'm I'm not going to find the area to the right, I'm finding the area to the left, because my alternative hypothesis has a less than sign.
So just to be on the safe side, if it said, if it was P is greater than 0.8, then we would do, for example, let's say, we would do 0.0013, I mean, 1 minus that, right? Okay, good.
Okay, so that is my p-value. My p-value is 0.0013. If we decide to use alpha at 5%, is my p-value larger or smaller than alpha? So if alpha is 5% and my p-value is equal to 0.0013, my p-value is less than alpha. So my p-value is considered small. So what do I conclude?
Yeah.
My p-value is less than alpha, so we reject the null hypothesis. And that means it is unlikely for us to observe a random sample where only 74% recommended gum. If the proportion of supporters is actually 80%. But I did observe a sample with only 74%. So the proportion of supporters is probably less than 80%. Okay? So we have reason to believe proportion
So if you were to ask us to interpret this, is that when you have the right hand test? Or like a simpler version?
Yeah, a simpler version of this. So this is kind of the verbose explanation. I guess a simple explanation would be our data provides evidence that the proportion of supporters is actually less than 80%. That would be acceptable. But this is a verbose explanation. And I just want to make sure that this line of logic and reasoning makes sense to everyone. So the math reveals that it's very unlikely for us to observe a random sample where only 74% recommend the gum if the proportion of supporters is really 80%. But we did observe a sample where only 74% recommended it. So that gives us reason to believe that the proportion of supporters is not really 80%. We gotta work quickly.
Yeah.
Okay, so the other hypothesis test involves two samples. So you have two samples, we're still dealing with a categorical variable. And so now, the question is, do the two samples have the same, not do the two samples, do the two respective populations have the same proportion, or are the proportions different? Okay, so for example, maybe sample 1 is a random sample of men, and sample 2 is a random sample of women. Okay. And we could say, is the proportion of left-handed men different from the proportion of left-handed women? Maybe your sample has 15% left-handed males, 17% left-handed females. Does that mean males and females in the population have different proportions left-handed? Maybe, maybe not. Or it could be, maybe you've taken a sample of males, sample of females, and then you say, what percentage of males paint their nails, okay? And what percentage of females paint their nails? And you find some proportion here, another proportion here. Does that reflect that in the populations the proportions are different? Okay. Sorry, that's a terrible example, but we have two samples, you get two different proportions, and you want to know, does that mean the proportions in the populations, are they different, or could they be the same? There are two samples, each with their own sample proportion. Does this mean the respective populations have different proportions? Or could they be the same? The process that we go through is very similar, except our selection of hypotheses is a little different. And the worst part is that the standard error formula is just horrendously ugly. There's not much we can do about it. But we'll go, alright? So when you have two samples, categorical variable, okay? Your hypotheses, this is what they will look like. Okay? The null hypothesis is that you've got two proportions, P1 and P2. P1 is the proportion in the population for population 1, and this is the proportion for population 2. This might be the percentage of all males that are left-handed versus the percentage of all females that are left-handed, or percentage of all males who paint their nails and percentage of all females who paint their nails, whatever. Okay? The null hypothesis is that there's no difference between those two proportions. So unlike the other ones, this one will always be P1 minus P2 equals 0. And then the alternative hypothesis is that P1 minus P2 doesn't equal 0. Or you could have P1 minus P2 is greater than 0, or P1 minus P2 is less than 0. Okay? Again, your choice of not equal to, greater than, or less than is determined by how the problem is written. It's not that bad. It's just P1 minus P2. Is it equal to 0 or is it something other than 0? Do not despair. You might also see